Hello, my name is Samuel Zhang. I'm from Palo Alto, California. My partner, Mr. Jonathan from California Tech University, is unfortunately won't be joining us today, so I will just be taking you guys through this presentation I have set up. So, first of all, my project is called Stepwise. In simple terms, it is a wearable device on the sole part of the human foot, which uses motion detection and also pressure regulation and thermal measure to regulate a human movement through the foot and measures in motion detection and pressure change. First of all, the main problem our product addresses, one is a golfer's power transfer efficiency. As a young golfer myself, I struggle with inconsistent swings due to improper weight transfer and also distribution of pressure during the swing. And since golf is a very prominent and very common sport in America, and many youngsters practice it and try to reach higher levels of the sport, this device provides efficient real-time feedback, helping golfers optimize their stance and also regulating their pressure through their practice and helping them achieve better performance. And the second, more general problem our product solves is the problem of flat foot pain relief. Uh, in the world, it is very common for a human being to be born with flat feet. Others might be more common with arches in their foot, which that arc in the foot really is an important factor in regulating a person's movement when they walk or run, because that arch reserves as a pain reliever and also a regulator in the balance in the foot, where if you don't have that common arch most people have, if you are flat-footed like myself, you would experience much more pain on the sole side of your foot and also a lot more difficulty in running and walking and exercises that involve that sort of body movement. And similar to golf, it helps regulate the pressure movement patterns, giving the wearer feedback and also how to balance their foot pressure and minimize pain to reduce discomfort in this process. And one point I wanted to make here to argue why our product, where there are so many wearable technology in the world right now. Well, first of all, this simple device is non-invasive and surgery-free. Issues like flat foot pain relief oftentimes need to see a medical attention or other doctors in studies of orthopedics to help relieve the pain. But this device, unlike surgical interventions or custom orthodontics, our solution helps with real-time analysis of feedback without the need for any sort of medical procedure. And as for now, our product compared to other golf devices such as simulators and other pain relief devices cost hundreds of dollars. Ours is much more affordable and is also a much more efficient option compared to expensive therapy or orthopedic solutions. And the term of instant feedback is also a huge product in improving the time efficiency for the wearer. Now, our general target audience for this device, primary users, obviously golfers, both amateurs and professionals, can help in any form of their sport, and also individuals with flat feet, specifically if they're experiencing a greater amount of pain, and the device helps with their walking posture and other exercises. Now, potential partners we considered are many golf training academies and professional coaches, especially if we're talking about the PGA Tour, or also at the same time, maybe partner with university coaches. That's also a good option. And also, including the medical side, orthopedic specialists, and other doctors as well. Sportswear brands is also an option where we are considering maybe collaborating with Nike and also the PGA Tour store, like I mentioned before. Now, how our device works, first thing we considered of using is, well, advanced sensor technology. which uses, like I mentioned, motion detection for precise data collection in real time. So it is live data. And one advantage our device has that many other golf devices and other exercise devices don't have is dual purpose functionality. Most of other products, other they either focus on the sports side of the performance or solely focus on orthopedic relief, while our device serves both markets very efficiently. And the real-time feedback and AI-powered insights is actually a really big part where it is achievable via a mobile app we created, which is directly compatible through the device with Bluetooth. And it can also give you instant feedback rather than every session you have to have a different analysis, which can be very time consuming. And it is also very flexible and customizable for different types of users, regarding the user's size, weight, etc., etc. And it can also, like I said, be made for both golf performance and also daily pain relief. Now, possible competitors of our product will definitely include such as Swing Catalyst and Body Track, which are both golf device companies, which they analyze weight transfer like us. And also, for pain relief, these are more effective than just traditional orthopedic insoles, which, unlike our device, they do not provide real-time feedback. And this is how our product stands out, where we combine all these sort of techniques and give reader a more interactive solution compared to existing other competing products. And here is a brief demo of our prototype. This is our very first version of the stepwise device. As you can see, it's insulated in the sole of this shoe. This is Mr. Jonathan's, actually one of his old shoes. And here you can see we used these, which is the first prototype of our device. You can see here is a Boron microcontroller. And these black pads are Velostat sensors. Some context Velostat sensors are very simple sensors. We regulate the pressure change in a human's feet, and this is the symbol sensor we use for the prototype, and the Velostat sensors serve as the main function for our pressure regulation. And the Boron microcontroller, I will explain that in just a minute how it will work. And here is a process of me running and building prototypes for our sensor. And as you can see, I am arranging the parts and connecting the physical wires to our device. And this for my controller, as you can see in my computer screen here, is connected to a particle.io app. And this is where we will receive all our changes in data. And the Boron microcontroller is a direct device paired to this particle.io page. Here are some numbers and graphs we included during the experiment. Mr. Jonathan actually conducted the experiment in his university using the prototype of our device. As you can see here, motion detection accuracy, as you can see here, we'll say it is pretty consistent. And here are some correct direct golf swings and the relative data of walking steps and just testing on how the motion detection is receiving the data. If it is, as you can see here, it's very consistent. And an additional graph, this is the actual pressure regulation response, which, as you can see, there are, over time, it's all in milliseconds, which means from what we see, the prototype deals with the response time to the pressure regulation relatively quickly. So that means there won't be any lagging or any slow responses when the wearer is in use of the product. And talk a little bit about our financial model of our product, where it's going to definitely have a subscription-based app, which we created a prototype of. And many partnerships with golf academies and orthopedic clinics and even universities such as that. And fundraising target investors, as I said, we also seek probably funding from all sports technology investors and also medical device funds. And we will also apply to the government health and also sports innovations funds if we want to do any grants or research funding. And here is a small map of how our device will connect to all of our different platforms. Here, as you can see, is the actual device, the symbol of the device, and it goes directly to the particle.io page, and then it will go to our Firebase database, where here is where we collect all the data, such as the users, names, passwords, time of use, etc., etc., this will be our data page, which will be basically a real-time database in Firebase. And then finally, this data will connect to the Stepwise app where we have set up. And only if the passwords and the user's credentials match what it says in Firebase, then you can access the app and log into your device. So the Stepwise device works similarly where it has a device ID and only the existing devices IDs in Firebase, only existing IDs that you can use and navigate, and then you have to collect Bluetooth to it, and then finally it will be wearable to the user. It seems a very time process, but once you use Bluetooth, it's actually a very simple process. Now, our prototype currently is, I will say, very affordable, and some maybe say it's too cheap. Where our first product here, obviously, we're not going to use wires in a final version of the product. That would be very unstable and also not the best in adaptability and also not very practical when used. As you can see here, Velostat sensor only cost about 50 cents. And Boron microcontroller development board is actually the most costly. And here is a brief overview of the cost and profit about our device. And it'll profit our first version. As see if we in a situation we sell it, it's going to profit about 20 to 50. And relatively ratio is 66% to 200%. And production cost right now, it is only about 25 to 30. And the prototype cost right now is the total of 60. So this prototype is still, a lot of people would say it's too cheap, and we're definitely going to make further adjustments to it to make it more practical and usable. Now, a little bit on future development. While we do have devices such as the Velostat sensors to detect motion change and pressure change, however, we do not have a machine or an AI mechanic system implemented to the app for, well, personalized feedback in real time. So we aim to develop a machine learning algorithm in our app, which we use Flutterflow to create this app and actually analyze user-specific movements and patterns and develop feedback over the time, whether that would be feedback in text or feedback in numbers. And another small weakness we have in our product right now is, well, the durability of our sensors. You can see on the photos that I demonstrated, the device is right now very fragile, and if you step enough on it, it will crack, and we will improve the functionality of the device by, I would say we wanted to add an auto calibration feature for the Velostat sensors to maintain constant sensitivity over time, so it makes the data a lot more consistent. And also at the time, we will at the same time design a protective shell over the device so that it won't get crushed when the user is in use. And here's my contact information if you guys have any further questions after the presentation. Thank you.
Thank you, Dr. Samuel Zhang. It was a nice presentation. Is there any questions from forum?
Sorry?
Yeah, I'm just asking questions from forum. I think
Uh,
there is no questions from forum. And thank you once again.
can you clarify? What do you mean by a form? Clarify.
Yeah, I'm just asking questions from forum. Is there anybody who wish to ask questions? But nobody ask any questions. And thank you.
Oh, okay. Yes. Okay.
Yeah.
Yes. Is there any further questions? Are there any?